This is part 2 of solving simultaneous equations. The first video dealt with using the substitution method. The beginning of the other video also introduced you to a graphical representation of simultaneous equation. I would recommend going to that video and having a look at the graphs I did in the beginning before starting this video. However, we're gonna continue with the same simultaneous equation, and using the same idea as we wanted before, we want to reduce our simultaneous equations to two unknowns. One method was substitution, the other is elimination. Once we reduce them to two unknowns only, either x or y, then we can easily solve the linear equation. So I'm going to start labeling my equations. I have equation 1, equation 2. Our aim is to get the coefficients to be the same. So if I have 2 next to the x, I want 2 next to this x as well. If I have 3 next to the y, I want 3 next to this y as well. Now, sometimes you won't get a direct method as to how you should change the coefficient. And here I can clearly see that I can multiply this whole equation by 2 and I could get 2x. However, if I actually wanted to make the y's the same, then I need to multiply the first equation by 2 and the second equation by 2, and I'm going to get a 6. So basically you're looking at the least common multiple. If that's a bit confusing, then it's fine. We can just focus on the fact that we can change this x to be 2x. So I'm going to multiply this whole equation by 2. And I'm going to rewrite my system of equations again. So I have 2x plus 3y equals to 7. And then you multiply every single term by 2. You do not multiply only the x by 2. You need to change the whole thing. Remember, this is an equation. It's balanced. If you change one number, you need to change the others as well in proportion. So we get 2x plus 4y equals to 10. Well, now that I got the x's to be the same, what I want to do is subtract the two equations from each other. So I'm going to do equation 1 minus equation 2. So if we start here, I can immediately notice that I'm going to get negative numbers, which is fine. We can deal with the negative numbers. However, it's not desirable because it's going to add an additional step. So 7 minus 10, that's going to give me negative 3. That's fine. However, on this side, we're going to get 3y minus 4y, which is negative y, and that's not preferable. So we can easily change that by swapping the equations. So we're going to swap the equations, and we're going to write 2x plus 4y equals to 10, and then 2x plus 3y equals to 7. Now we can subtract the two equations. So just as you do with subtracting normal numbers using a column method, it's the same idea, except that we're going to do it term by term, and there are equals and positive signs in there. So I'm going to go term by term. 10 minus 7, that's 3. And then 4y minus 3y, that's just y. And then 2x minus 2x, that's just 0. It cancels out. That's the whole point. If you end up with an x and a y at the end, it means you did something wrong and you need to look back at your multiplication or your swapping or your subtraction. So I'm going to bring in the sign, so I'm going to bring in the equal sign. I don't need to bring the positive sign here. Sometimes you need to do an additional step. With this case, we already got to our answer, which is y equals to 3. Sometimes you might get things like 3y equals to 3, and you have to divide by 3 on both sides to get y equal to 1. However, in this case, we don't have to. So we got that y equals to 3 using this elimination method. So this is the big part of the elimination method. So first you want the coefficients to be the same, then you can subtract the two equations. Swapping is optional, you don't have to do it. And then once you've subtracted, do any additional steps you have to do if there's any coefficients in front of the y, and then you get your y value, or your x value, depends on which one you eliminated. So next, because I have my y value, I can substitute this y value into any of the equations. I can substitute it into this one that we multiplied by 2, or the first original equation, or the second original equation. I'm gonna go for the second one because it's easier. So we're gonna find x, and I have x plus 2y equals to 5. Well, I know y is equal to 3, so x plus 2 times 3 equals to 5, x plus 6 equals to 5, and you can solve it and notice that x is equal to -1. So your solution is x equals to -1, y equals to 3, which matches the coordinates we got in the beginning, in the first part of the video, in the graph, and using the substitution method. I would recommend trying to go back to this question, try different eliminations, try to eliminate your y instead and see how you can do that. Try numbers where you'd have negative coefficients and see how you would do that, and attempt a bit more harder questions. As long as you understand the basics of elimination methods, then you can try and attempt any harder questions.